Welcome everyone, I'm Adam. And in this problem, we're going to be verifying the identity tangent of sine inverse of x is equal to x divided by the square root of 1 minus x squared. Again, in identities, what we want to do is show that one side of the equation is equal to the other. And generally what we do is take the more complicated side of the equation and work with that first. Now this is a little unique, obviously in two parts. Number one, only one side of the equation has trig functions involved, and we also have an inverse trig function. So what we're going to do is start with the left-hand side and work with that and try to show that it's equal to x divided by 1 minus x squared. So starting with our left-hand side, our tangent of sine inverse of x. So the sine inverse of x, first off, might look a little intimidating, but if we just remember a few things, then when we take the inverse of a real number, what that gives us is an angle. So on the inside of tangent, sine inverse of x is just representing some unknown angle, which we'll call theta. So this problem really reduces to finding the tangent of, say, some angle theta, which we've done things like that before. Now to help us with this, we're going to look at some right triangle trigonometry. So let's look at that. We're going to draw some general right triangle with, say, some angle theta, which is our sine inverse of x. And in this right triangle, with our angle theta, we have our opposite side, hypotenuse, and our adjacent side. So finding the tangent of theta, if we remember our SOHCAHTOA, the TOA in SOHCAHTOA tells us that tangent of theta is equal to opposite over adjacent. So with our right triangle, that's what we're going to try to find. The value of the opposite side and the adjacent side, and if we divide them, we'll get the tangent of what the angle theta is. Now how are we going to do that? Well, starting with what we know, we're taking theta is the angle sine inverse of x. Well, what does that tell us? Well, that says, taking sine of both sides, that sine of theta is equal to sine of sine inverse of x, which of course is equal to x. Namely, not just x, but we'll think of this as x over 1. Now again, with our SOHCAHTOA, we can think of the sine of theta is equal to the opposite over the hypotenuse, which is exactly what we have here, x over 1. So that tells us that our opposite side is equal to x, and namely, the hypotenuse is going to be equal to 1. So we got two sides of a right triangle filled out, and with our tangent, we want to find the opposite over adjacent. We have the opposite of x, now we just need to find the adjacent side. Well, we've done this before with basic algebra and geometry. We have two sides of a right triangle, so we can just use our Pythagorean theorem, namely the sum of the square of the two sides, which right now, let's just call this adjacent side A. We have that a squared plus the sum of the square of the other side, x squared, is equal to the hypotenuse, 1 squared. And we can solve for our adjacent side a. So we get that a squared is equal to 1 minus x squared, and taking square roots of both sides, technically remembering that when we take square roots, we have both positive and negative, but being that our a represents a length, meaning it's a positive distance, we're going to take the positive form of the square root. So positive square root of 1 minus x squared. So there's our adjacent side. Positive square root of 1 minus x squared. So using our formula here, we can put this all together in that tangent theta is equal to our opposite over adjacent, or x divided by the square root of 1 minus x squared, which verifies our identity. Thank you very much.